Oh, hello everyone. The next thing I want to go in with you is called Venn diagrams. Okay, Venn diagrams are just circle overlapping or distinct and stuff like that. So all these examples that I have right there are Venn diagram. It's okay. So if you look at the first one, you have the set A. This is a set A right there. It's right inside of the set B. There's a set B. See the blue set? Oh, maybe that color is too dark, so I won't color it at all. Or if I can find it, no, there's no lighter color than that. So you have a set A completely inside of a set B. Therefore, this Venn diagram representing A is a proper subset of B, because it's inside of B, but it does not equals to B. See that? A is inside of B, but it does not equals to B. So A is a proper subset of B. You look into the second diagram. They shade the region in between A and B. That shaded region representing A intersect B. That's everything that is common between A and B. The third diagram, you see that they are shading. You see that red, all these red marks? They're shading everything in A and in B. Everything in A and B. Thus it representing A union B. A union B. You see that? Okay. Sorry, I just remind myself that I have to shade all those, so it makes you a little bit confusing. I'm talking about this one right here. A union B. The next one. I shaded everything outside of A. See that? So I have a universal set that's noted in red. And then I shaded everything but A. Therefore, that must be the complement of A or A bar. And if you look on the last one, A is on its own, B is on its own. They don't even touch. So they are called disjoint set. So those are called Venn diagram. And the Venn diagrams is the way of visually describing the picture of how the two sets are relating to each other. Okay, let's do some example. All right, first diagram. It says, example, use the Venn diagram to illustrate the relationship. We want A union B intersect with A union C. So I'm going to do A union B first. A union B are everything in A and everything in B. So that whole yellow part is A union B. I'm going to use a different color, and I'm going to do A union C. So in green, A union C, that's A. Union C, that's A union C. Right, everyone? Okay. And then they want me to illustrate A union B. Okay, I'm going to walk back a little bit because I don't want to shade it in too much. Because when you shade it in too much, the color change and I can't tell them apart. So there we go. Okay, so the green part is A union C. Now we want to find out A union B intersect with A union C. So where do they intersect? Okay, they intersect right there. You know what? I'm confusing now because I can't tell the color. So let me just shade it in by these. Probably that would be better. I am so sorry because sometimes the shading color just kind of blur me out. So this blue line, that probably would be the best way. All those things that shaded with blue lines are A union B. Then I'm going to use red for the next one. Everything shaded in red is A union C. So there we go. Now it's a lot clearer. Everything that's shaded in red or striped with red are A union C. So we want A union B intersect with A union C, which means the part that have both colors. So the part that have both colors is this. That have both colors and that. So that part will illustrate A union B intersect with A union C. That will be the best one right there. Okay? When I use the color before, I just colorblind in the end. So I am so sorry. All right, next one, number 2. It says B bar intersect B bar. Oh, I forgot that. What I mean is B bar intersect with A union C. That's what I want. I forgot to put the things in between. So B bar intersect with A intersect C. So let's do A intersect C first. Here's A right there. A intersect with C is this region right there, the one that I just shaded. That section is A intersect with C, right? That's the part that both of them are the same. Then I'm going to use this to illustrate B bar. So everything but B, okay? It's probably the best way to do is to isolate to, okay, so here we go, everything but B. This is tedious work, eh? So let's shade it in. Everything but B. I love doing this, but sometimes it's kind of confusing at the same time. So you see the yellow shade that I put in? The yellow shade that I put in. And that yellow shade will include this part as well. And I chose the wrong color for the middle part. So you know what? I'm going to go back and I'm going to try to my best to erase that out. Oh, there we go. And I'm just going to shade it in with this. So you can see that. It's easier to see this way now. So all that yellow is also in there too. See, the yellow is also in there? And that all yellow part is called the B bar. So this is B bar right here, shaded in yellow. And you can see that it's also shaded in there too. That little spot right there has been shaded too with yellow. Therefore, the intersection of B bar and A intersects C. I'm going to use a strong color. No. That will be that little piece right there. Maybe not. Let's use this. It's going to be that little piece right there. Correct? That's when the yellow region is intersecting with the blue region. Okay? So I'm going to isolate down here. That is B bar intersecting A intersect C. All right? Okay, let's move on. Over here, if you don't mind, I'm going to go back. Oh, no, I don't have to do it because the questions already have it. Use the figure to find the relationship. It doesn't hurt to do this so that you can actually check using the set notation. So first I'm going to put the universal set down. Okay, now in set notation, it will contain 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I just noted that I'm missing. I didn't put the number 8 down. So let me find it in my notes so I can put that in. Because I am sure there is a number 8 that I meant to put in. But I just didn't, I forgot to put it in. So 8 supposed to be right, 8 supposed to be right there. It's in between C and B. Okay. All right. So that's the universal set that I just put down from 1 to 10. A set consists of 1, 2. So you just read the number inside of A. The number inside of A's are 1, 2, 3, 4, 5. See? 1, 2, 3, 4, 5. You with me, everyone? All right. So those are the elements in A. 1, 2, 3, 4, 5. Elements in B. B would be, let me count. 3, 4, 8, 9, 10. See that? 3, 4, 8, 9, 10. So let's list that down. 3, 4, 8, 9, and 10. Then list the element in C. This is just use your check. I always do that to check my Venn diagram to see if I'm correct. So, C, okay, let's go. 5, 4, 6, 7, 8. So 4, 5, 6, 7, 8. So 4, 5, 6, 7, 8. So this question can be done in set notation, and it also can be done in the normal notation as well. I don't know what just went wrong there. My page is kind of turned to this way. I don't know what I did. Oh, okay, made a mistake again, so I shouldn't do this. Oh, there we go. The page is big again. It's all right. So I want to do A union B first. A union B. Okay. So you could use this or you could use that, whichever is less confusing for you. If I'm forced to do it by the Venn diagram, after I do the Venn diagram, I always go back to the set notation to check my work over. And quite often I do that. All right. So A union B. So from the Venn diagram, A union B would be everything in A added to everything in B, right? And let's read out the numbers from there. 1, 2, 3, 4, 5, 8, 9, 10. So it would be 1, 2, 3, 4, 8, 9, and 10. So you're with me, right, guys? So follow it again. That's A union B. Everything together. 1, 2, 3, 4, 5, 8, 9, 10. I'm missing a 5 in my set. So I am going to go back. And I'm going to fix my work right here. Supposed to be a 5. And then an 8 and a 9 and a 10. Go to my set notation. I want A union B. Look at them. 1, 2, 3, 4, 5, 8, 9, 10. So yeah, it's checked out using the set notation. So I always do that just to make sure that I'm correct. The next one I want to do is B union C. So B union C. Here is B. Here's C. So B union C will be all the numbers that you found in there. I'm going to list them down. I'm going to go back and erase it. So smallest number is 3, 4, 5. So read all the numbers in the yellow region in order. 3, 4, 5, 6, 7, 8, 9, 10. So basically just less 1 and 2. Are we good? Is everybody okay? All right. Now C bar. C bar is everything but C. So I think what I'm going to do is I'm going to color C and then leave the white space for C bar. So there's C right there. C bar would be everything but C. C bar is everything but C. So in C you have 4, 5, 6, 7, 8. So that leaves C bar for 1, 2, 3, 9, and 10. Right? 1, 2, 3, 9, and 10. Are we still okay, everyone? Okay. I'm going to make this a little bit longer tail so it looks nicer. Let's now do number 4. Okay. Number 4, it says it wants you to find A section C. A intersect with C. So A is all this. Correct? But we want A intersect with C. So A is up here. B is down here. A intersect with C would be that sections right there. You see it, guys? I didn't shade it nice enough, so I'm going to shade it again. Oh, maybe the line is too big, so go in a bit. That is A intersect with C. Correct? So there's only 2 numbers there. There's a 5 and there's a 4. So 4, 5. 4, 5 would be A intersect with C. Number 5. So let me get that out first. Number 5. We want C bar intersect with A. So C bar would be everything that is not C. So maybe I should say shade C. If C is a yellow part, then C bar is everything in white. Correct? So C bar is everything in white. Right? So then, to find C bar intersect with A. C bar intersect with A would be this part right here. The green part. That's where A intersect with the white part. So it's 1, 2, and 3. That one is a little bit iffy. So you know what I'm going to do? I'm going to check it using set notation because it looked kind of iffy to me. All right. So if you can't really tell by the Venn diagram, then check it out using the normal way, the set notation. So C is 4, 5, 6, 7, 8. So C bar would be 1, 2, 3, 5, 6, 4, 5, 6, 7, 8. So leaving in 9 and 10. Correct? That is C. So C bar must be everything that's not in C. So 1, 2, 3, 9, and 10. Correct? And then A is 1, 2, 3, 4, 5. So now we want C bar intersect with A. So C bar intersect with A. 1, 2, 3. And that's it. So we were correct. Okay, so it turned out to be exactly the same answer that I got before. But with the Venn diagram, it's a little bit harder to see unless you shaded it really well. It's okay? All right, now I feel like I can move on. So I'm going to move to C. No, we'll move to number 6. If you don't mind, I'm going to put these lines in so I remember which number is what number. And I won't get them confused with the rest of them. So just give me 1 minute to do that, okay? So your note looks a little bit cleaner. There we go. Okay. So in 6, I want A intersect B intersect C. So first, I'm going to find A intersect B. A intersect with B is this region right here. That's A intersect B. That's where they have in common. Then I want that intersect with C. So the yellow region intersect with C right there. You see? The yellow region intersecting with C or coincide or overlap with C right at 4. Therefore, answer is going to be just 4. And if you want to check that out, you can go ahead and use the set notation to check that out. A intersect B would be, if you look at A and B right there, A intersects with B at 4. That's the only number that they intersect. And then C would have 4, 5, 6, 7, 8. Thus, their intersection is only 4, and yeah, we were correct. Okay, so always check it out if you're not sure. Now, I can't see this one very well from the bottom, so I'm going to try to turn the screen to see a little bit, to see if it would give me a longer side. Yes, it does. So hoping it doesn't give you a headache there. So hoping you can still see the screen the way it is. All right. So the next one I want to do is A union with B intersect C. So first of all, I would do B intersect C. B intersect C is that regions right there. B intersect with C. Then I want A union with it. So let's use a bigger color. A union with it, there's A. Union mean add everything together. So not only you taking that part, you're taking everything else. So it would be that yellow region that I have right there for you. I mean, not yellow. That's not yellow. That's orange. So we have 1, 2, 3, 4, 5, 8. 1, 2. Oops. Now I can't write proper because I'm having my screen standing up. Pardon me. So 1, 2, 3, 4, 5, and 8. Those are the element in A union with B intersecting C. I have to write the 8 back in because I just erased it. All right, let's go to A bar, union B bar. All right, this one give me the creep. It's kind of scary a little bit. All right, so B bar. So let me shade B first. That's B. So everything white would be B bar. Right, guys? Everything white would be B bar. So it would be 1, 2, 5, 6, 7. Correct? Let me put that down here so I remember. B bar would be 1, 2, 5, 6, 7. You're with me, right? If B is 3, 4, 8, 9, 10, then B bar is 1, 2, 5, 6, 7. I also want to find A bar. So let me shade A in. There's A. So A bar would be everything outside of that green circle. So A bar would be 6, 7, 8, 9, and 10. Right, guys? Look. 6, 7, 8, 10, 9, and 10. It's okay? So to find the union of those two together. Oh, okay. So the union would be everything. 1, 2, 5, 6, 7, 8, 9, 10. So I'm going to put the answer down. Union 1, 2, 5, 6, 7, 8, 9, 10. So the only two numbers that's not in there is the number 3 and 4. It's okay? We all right? Okay, so take that away. If it feels like it's too difficult to use the Venn diagram, then use this method. Use this method. Okay, you use a Venn diagram up to the point where you find, oh, okay, let's see. Where can I read and where can I cannot read? So you go step by step, and I find that works for me. Next, I wanted to find A intersect B, union C, and complement of that. So it does get really, really, I would say, messy. So I don't think I want to use the diagram to do that. I'll use partially the diagram, but not everything. So I'm going to use the diagram to find A intersect B. So A intersect B would be everything there. See, A intersect B would be everything there. And A intersect B would be 1, 2, 3, 4, 5, 8, 9, and 10. I'm just reading all the number. Oh, not intersect. I'm sorry. It's not union. So please pardon me for a minute. It's not union, it's intersect. So A intersect B would just be right there. I am so sorry, guys. Just the 3 and the 4. 3 and the 4. Forgive me, okay? That's A intersect B. Then union with C. C is everything here. So if A intersect B, union with C, that would be the yellow shaded regions right there. Okay? So A intersect B, union with C will be everything in that yellow shaded. So it would be 3, 4, 5, 6, 7, 8. Therefore, A intersect B, union C bar will be everything in the white region. You with me, right, guys? Everything in the white region. Right? And in the white region, you have 1, 2, 9, and 10. So label it down. 1, 2, 9, and 10. Okay? So your next teacher probably would go more into this, into the Venn diagram with you. I just want to introduce it, and then hopefully that your next teacher will go through the Venn diagram and you'll understand it a little bit more. Okay, I won't be testing you on this because I'm leaving. This would be my last lesson with you for this semester. So thank you so much, and bye-bye for now.